Welcome back with Professor Solis and Strategies for Success. So we're going to look at relations and functions. So today we're learning about relations and functions. And why does it matter? Functions are one of the most important ideas in algebra because they describe how one quantity depends on another. For example, we determine if we have relations, we determine if that relation is a function, vice versa. So first thing is, let's define a function is where we have no repeating x values. And a relation, every function is a relation, but not every relation is a function. We'll write that towards the end. Okay, so we have three ways to determine a function. So the three ways are, one, we test with a set of ordered pairs. The second, we look at graphs using the vertical line test. And we tend to abbreviate VLT, stands for vertical line test. And we only use it with graphs. And then the third is mapping diagrams. So we have three ways to test functions. We don't need to use all three, we just use one. But let's take a step back. So when we say function, we want to use f of x. That's our notation for a function. In order to have a function, I'll put it right here, notation. So, notation, f of x. A lot of us have learned f of x equals y. X is our input. Y is our output. So we're going to be looking at that with sets of ordered pairs first. So let me erase and then we will look at that. All right, so be a little patient with me as I erase this. And make sure it doesn't look where it smears on you guys, okay? Sorry, I'm not erasing very well. All right, so we'll look at sets of ordered pairs first. So when we write sets of ordered pairs, let me get a little bit more here to erase. We have to make sure, okay, I'm going to try this one more time. Y'all stay with me. This eraser. All right, we're going to get it nice and clean here so you can take some good notes. All right, so we're looking at sets of ordered pairs for our example. So let's say we have -3, 2, -4, 1, 2, 3. When we write a set of ordered pairs, we need to have a brace around the ordered pairs. Then I'm going to erase the example word here. Then you set it equal to a capital letter. I'll just put capital S. So when you have sets of ordered pairs, you need a capital letter, the braces, the squigglies, and then X and Y in more than one pair. What we look at to see if we have a function is we look at the X values. If the X's repeat, it's not a function. If the X's do not repeat, then we have a function. So this would be an example of a function. That's a yes. Now let's look at another set of ordered pairs. We'll use -3, 2 again. We'll use 2, -3, and then we'll use 2, 3. Close the set. Now here I have a -3. Okay, I have a 2, does not repeat. Uh-oh, I have another 2. These two x's repeat, so this would be not a function. So that's how we use sets of ordered pairs to see if we have a function. You look at the x values. Now the second method, so this was the set of ordered pairs. The second was looking at graphs. So I'm going to draw a few graphs here. And we're going to determine if these are functions or not. All right, so I'm going to draw a circle graph. I'm going to draw a wave graph. I'm going to draw a line graph. And then I'm going to draw an M graph. So using the vertical line test, we draw a vertical line. If I draw this, I touch my picture 2 times. That means the x's repeat. So this is not a function. Then I go to my next graph. I draw a line here. I only touch my picture 1 time. This is a function. This line graph, draw my vertical line 1 time, function. This M, if I draw the line here, draw it here, I still touch it once. So we have a lot of examples of functions. When you draw the vertical line test, if it touches more than once, not a function. So there's our sets of ordered pairs. There's our graphs. Now we want to look at the third, which is mapping diagrams. So, in case we forgot, a mapping diagram is like having an oval of data. And I want us to think about data isn't always numerical. It can be nominal. Nominal means names. So let's look at that. So our last way to test for functions is mapping diagrams. Okay, so mapping diagrams is like having an oval and an oval. The first oval is all your x's. The second is your y's. They don't label it. I'm just doing that. So if I put in, let's say, names, Sue, Lisa, Mark, and we'll say y's their ages, 17, 18, 22. Lisa's 22, Mark's 18, Sue's 17. This is what we call a mapping diagram. Sue is only 17. She's not 18 also. So this passes the function test because there's only one x to one y. Mapping means I map x to y. Now, I use names, I use numbers. So I want you to understand that data isn't always just numbers, okay? But if I put it in order and I said Sue, Mark, Lisa, and I had the ages 22, 23, 23, and I map this way, it's still none of the x's repeat going to the y's. Now the y's repeat, but that's okay. It's about the x's. So these are examples of functions that are mapping diagrams. And when there's no crossover on the mapping, we call that a 1-to-1 function. 1x to 1y. So I hope that helps you remember functions. Relations are, the definition of relations are sets of ordered pairs. So I said I would come back to this to conclude. Every relation is a function. So every relation, I'm going to put it over here. Every relation is a function. But every function is not a relation. Okay, every function is not a relation, but every relation is a function. So keep that in mind, and that's also in your book. So hopefully we're opening up those ebooks and reading as well. All right, talk to you guys soon.